Is this on? Hi, everyone. My name is Jack Minardi. I'm a software developer at Enthought by day, and I like to play with hardware stuff in my free time. So typical computing is usually you write programs that interact with data on disk. You'll load Usually you'll interact. Is this good? Okay. Usually you'll interact with data on disk, read and write information from your drive, and if you're lucky or unlucky, your programs will draw pictures like this. But physical computing is in contrast to that. It works with data on disk and maybe has user interfaces, but it also has actual devices that interact with the real world. It has actuators that can move, and it has sensors that can sense and read in data from the physical world. This is the Mars rover that's currently on Mars. So today's goal, I'm going to demonstrate how to interact with the Raspberry Pi, how to communicate with your Raspberry Pi from your laptop using a library called ZMQ, which is a socket library, and then how to use the Raspberry Pi to control an LED to blink it, also to control a servo. A servo motor is a small motor that you can set the arm position to any number of angles. Also how to read analog sensors such as this potentiometer, which is a variable resistor, using a off-board chip to aid in the analog to digital conversion. So here's an overview of some of the topics that I'm going to be covering. Basically, this is all enabled by the Raspberry Pi. If you haven't heard of it, it's a small credit card-sized Linux computer that costs only $35. It has the typical things you would expect on a computer, video out, audio out, 2 USB ports, Ethernet, and it has HDMI out. But what makes it truly special, I think, are these GPIO pins that I've selected here, I've highlighted. That stands for General Purpose Input Output. Those are basically pins that you can set a binary value of 1 or 0. And that's represented in the physical world by 0 volts or 3.3 volts. And it's only binary. You can only set high or low. That's important. We'll talk about that a little bit later. You can also read binary values from some external sensors, so you will be able to read, is my pin currently high or low right now? And that's how sensors communicate back in to the Raspberry Pi. And a sensor is basically anything that reads data from the world, and an actuator is anything that can affect the world through motion, light, sound. So these are the parts that I'm going to be using today. The Raspberry Pi. With the Pi, you need an operating system. I'll put a link to the operating system I use called Occidentals in the next slide. You also need a network connection. Then you need a laptop to communicate with the Pi, a potentiometer, or really any analog sensor that you want to use, a servo, an analog to digital converter, and then these things here on the right are some of the other hardware that we're going to be using, an LED, a breadboard to prototype, just makes it easy to connect your components, then some jumper cables and various resistors as well. So this is the operating system I mentioned before. If you just go to the Raspberry Pi website, they'll tell you to download an operating system called Wheezy. It's Debian-based. It's quite useful. However, this company called Adafruit, which makes lots of hardware components, has created their own operating system called Occidentals, which basically comes with lots of the libraries that you will want to use if you want to do hardware control. Anytime you buy a product off their website, or often, it'll come with tutorials on how to use it and maybe even some sample code. And that code expects you to be using their operating system, or their flavor at least of Wheezy. So I recommend downloading Occidentals if you want to do hardware control with your Raspberry Pi. And that's the URL to find it. So, like I said, today I'm going to give 4 quick demos and explain the code that goes behind them. For the first one, I'm just going to do basic blinking of an LED. Then I'm going to read a potentiometer, and then stream data using ZMQ, and finally control a servo from my laptop over ZMQ. So the first project is blink an LED. If you're not familiar with LEDs, it stands for light emitting diode. A diode is a circuit element that allows current to flow one direction but not another. Typically, the small LEDs that are very common work with 10 to 30 milliamps of current. Any less than that, they won't light up. Any more than that, they'll light up really bright and then go out. And also, they usually drop about 2 to 3 volts. You can find, if you're lucky, you can find the data sheet that comes with your LED, but most LEDs don't come with data sheets, and you just have to know these things. And so if you just connect an LED straight to the pins on the Raspberry Pi, it'll flow way too much current through them and pop them quickly. So you need to pop a resistor in there to limit the current flow. And if you feel like doing math, you can use this equation. But if not, basically a kilo ohm is fine for most LEDs. Kilo ohm resistor. So to actually control the GPIO pins, you need this package, which comes with Occidentals. But if you didn't take my advice and you wanted to use your own operating system, you can get it through apt-get or pip. It's on SciPy. So this is it. This is all you need to blink an LED. This circuit on the side, on the right side, is the roughly 1,000 ohm resistor in series with the LED. And the top of the circuit is connected to GPIO pin 12 and loops through in series to ground on the Raspberry Pi. And this is all the code you need. The important bits are these, though. You import rpi.gpio. Now, there are 2 modes that the community uses, two conventions for pin numbering. I think the most common is BCM. That's Broadcom's, which is the chip makers, their pin numbering conventions. But there's also board pin numbering conventions, which just counts in order down the board. I always use BCM. I think most people you'll find online always use BCM. The only difference is that that's just a convention for which number refers to which pin. So I set it here to BCM, and then I set up pin 12 as an output right here. And then basically I just call output, feed it which pin I want, and then I feed it a value, 1 or 0. 1 is output high, which is 3.3 volts. 0 is output low, which is 0 volts. So this code just cycles through, outputting high and low. And I can demo this if all works out. I can demo this working. So here I'm actually SSH'd into the Raspberry Pi. Let's make this a little bit bigger. And Raspberry Pis always come pre-installed with Python, so that makes life a lot easier. And I'm just going to run this blink LED script. And you got to run it as sudo. To have access to the GPIO pins, you need to run as root. Okay, and if you're in the front row, you can maybe see the LED blinking, but I have a camera here just to prove to you that there's an LED on there blinking. Okay. So the second demo I want to go through is reading a pot or potentiometer. A potentiometer is a variable resistor. It's basically just a resistor with a slide on it that allows you to connect at any point in the resistor. So you change the resistance by moving the dial. You apply voltage to the outer pins and you sense the knob position on the inner pins. And so how this sensor is very basic. It's an analog sensor, meaning you read the values by reading the voltage on the pin. Any voltage between the min and max, which on the Pi is 0 and 3.3. And like I said before, the GPIO pins are only binary, so that makes it tough to read analog pins. If you've worked with Arduinos before, they have analog sensors or analog reading built into the board, but the Raspberry Pi has no such chip. So you need to use an analog to digital converter. This chip right here is about $4, I think, on Adafruit. You can probably find it cheaper elsewhere. But like I said before, Adafruit gives great tutorials and walkthroughs. So I have a link to the page there. This has 8 10-bit channels, meaning you can read analog values between 0 and 1024. And the Raspberry Pi uses a protocol called SciPy to communicate with it, which I believe stands for Serial Peripheral Interface. It's basically a binary protocol that's very common in low-level hardware control. And to use SciPy from Python, you need the SciPydev package, which can be found here on GitHub. That's installation instructions. And this link at the bottom will have a lot of information about the actual chip, and it'll explain in more detail how to communicate with it. This right here is all the software and hardware you need to communicate with the MCP 3008 connected to the Raspberry Pi and a potentiometer. So on the left is the potentiometer connected to 3.3 volts and ground. To make this diagram easier to understand, I kind of broke the Pi up into just labels. And that chip that's the MCP 3008 in the middle. You got to connect a few wires to it so the Pi knows how to communicate with it. The master out, slave in, and the master in, slave out is the two communication lines. Then there's a clock line as well. And that's the code on the left. The important part really is just this. If you read the data sheet of the MCP 3008, it'll explain to you which bits you have to send to give it a read command. And this is basically using Python and some bit shifting to send the correct series of bits, telling it which channel you want to read on. And then the out value is grabbing just the 10 bits you need by ANDing one of the bytes with 3 to mask out all the upper bytes, and then just shifting that over and adding it to the lower byte. But that website I posted or linked on 2 slides previous explains this in much more detail, exactly what's going on there. So I will, again, hopefully demo this and it works. I'll post a link to all my code. I've pushed it up to GitHub, so if you want to play with this later. So I just called that code right there I ran. Let's see. Okay, can you all see? Well, I should move this. So it's just printing the values, and then as I move this knob, it's printing the values that it reads. And as you can see, it's between 0 and 1023, because it's a 10-bit analog to digital converter. Okay, the third demo that I want to give is streaming data. Unfortunately, this one doesn't use the Raspberry Pi, I don't think. It just goes over using the 0MQ networking library. This is a very popular sockets library, described as TCP on steroids, I've heard. You can install it using apt-get, or it's on PyPy under PyZMQ. It has bindings for many languages, but the Python bindings I think are excellent, and much simpler to use than the standard network sockets library. This is all the code you need to implement to get a client and server in ZMQ. The important bits, however, are just these. You have a reply socket and a request socket on either side of the wire. And then the server binds to that socket and then just blocks on the receive method until someone else calls a send. And then the server can send data back. Okay, so now what do we do with that data that we're streaming over the wire? Say we use the MCP 3008 to collect some data and we stream it using 0MQ. We want to visualize it somehow. And I'm going to demo visualizing that using Chaco and Enamel, which are two open source libraries from my company Enthought that just make it easy to quickly visualize data, to plot it, and interact with it. You could install these either from Canopy or just install the Enthought tool suite, which is on SciPy, which is just these packages and a few others. And this is how you build a view. It's not very important for this talk, but this is just minimal code right here to pop up a plot. If you've worked with Matplotlib, you might wonder why you have to write so much code just to make a plot. But the power here is that it's interactive and it's easy to embed and make more complex applications from it. And again, those are the important bits. And that code will produce just a basic plot like this. Now I'm going to demonstrate, hopefully, streaming data from the Pi over the wire and plotted using the Chaco library. So I'm just running IPython as root because I have to instantiate one of these classes. So I've instantiated my server, and then on my laptop I'm going to run the client. Whoops. Which (2027). Okay. It's connecting to the wrong port. Okay, here we go. So this is connected up to this 3-axis accelerometer, plotting X, Y, and Z, streaming over ZMQ to a Chaco plot. All right, and I got to go pretty quickly through this last one. So the last one is servo control. A servo is just a small motor that you can set the arm position. It uses something called pulse width modulation, which is basically sending pulses, and you send the width of the pulse is what is important to the servo. If you send a 0.5 millisecond pulse, that's telling the servo, go to your minimum arm position. If you send a 2.5 millisecond pulse, that says go to your max arm position. And that timing is very critical. Python and the Raspberry Pi can't control a servo with that precise of timing without help of a special library that I'll mention. And that is a kernel module called Servo Blaster, which uses, I think, memory control blocks to bypass the CPU and give you quite precise timing. And basically that puts a file that you write to. You write basically the servo number and the value. Then if you connect up a servo like this and use a library that I wrote called Robot Brain that provides a basic object-oriented layer around servo control that allows you just to instantiate a servo on a given pin and then set the value between 0 and 1, and if you give it the min and max positions when you instantiate it. And actually I have a demo. Let's see if I can get that quickly running, and then that's it. Maybe. Okay, well, that's not working. Questions?
Do you recommend Raspberry Pi or Arduino?
So the question was, do I recommend Raspberry Pi or Arduino? If you want to do like low-level servo control, the Arduino is certainly easier. You don't need kernel modules or anything. But if you want to do anything higher level, like streaming data over the wire, the Raspberry Pi makes that much simpler because it's a full Linux distribution. You have Python on it, and you can code in a comfortable language. You can actually communicate, use them both really, and have them both do what they're best at and communicate over serial to talk to and from. But really, it depends on your project, I guess. Yeah?
Are these libraries easy to get on the repositories for Raspbian?
Yeah, they should be easy to install. The Occidentals distro that I mentioned is basically Raspbian plus these libraries.
Okay. We are running out of time. Thanks for coming.
Thank you.